So, after today's lab, let's just clarify to make sure that you understand all the reasons that we have seasons. So, let's pretend if the Earth was perfectly balanced, like this animation, that we didn't have a tilt. Well, if we didn't have a tilt and we were perfectly vertical, then we wouldn't have seasons. And the sun would always rise and set at the same time every day. We would have exactly 12 hours of daylight and 12 hours of night. Now, normally this only occurs twice a year on special days that we call an equinox. And we're actually having the fall equinox coming up very quickly. Every part of the Earth would see the same amount of light as the Earth is rotating. The North Pole, the equator, the South Pole, and every latitude in between would be receiving 12 hours of day and 12 hours of night. But we know that's not the case. The Earth isn't perfectly balanced on its axis. It is tilted at 23.5 degrees. So because of this tilt, this is what allows us to have seasons and what allows our days and nights to change with the seasons. Now, not only is the tilt having a big part of to do with seasons, but it's also the revolution. The definition of revolving or revolution is the movement of the Earth around the sun. Now, unlike rotation, where it is just spinning on its axis, the Earth is moving around something. It is revolving. Now, as the Earth is revolving around the sun, it is also rotating. We also get a unit of time from this. It takes exactly 365.25 days for the Earth to make one complete revolution, which means the Earth rotates 365.25 days in the time it makes one revolution. So you could create a ratio from that. The tilt changes how much sunlight each part of the Earth receives, and that was something that the video also talked about from yesterday, how we receive direct and indirect sunlight. Now look at this image on the right. If the arrow was hitting the Earth, notice how it's almost hitting it perpendicularly. That would be direct. Whereas you move farther south and farther north, it's hitting it more at a obtuse angle, and as it said in the lab you discovered, it's spreading the same amount of heat and light over a greater distance. So the heat is greatly reduced, making the season colder. Now, with the tilt, it also makes our days longer and shorter, and it's what causes our seasons. As I said, if the hemisphere is tilted towards the sun, we are going to receive more direct sunlight, and we call that summer. Now, whatever the northern hemisphere is doing, just keep in mind the southern hemisphere is always doing the opposite. So if we are having summer and we're tilted towards the sun and having direct sunlight, then that means the southern hemisphere is tilted away from the sun. They're in winter and they have indirect sunlight. And again, if you look at the equator, notice if you're tilted towards the sun, you have a larger amount of day and a smaller amount of night. In the summer, we are tilted towards the sun and our days are longer and we receive more direct sunlight, which is why it's hot. Actually, the part of the Earth that receives the most direct sunlight when we are in summer is the Tropic of Cancer. And if you look at this latitude right here, the Tropic of Cancer is in the northern hemisphere, so that is why we're the warmest. If you were to flip it and look over here, when we are facing away from the sun and we are in winter, the southern hemisphere is facing towards the sun and they are in summer. And the part of the Earth that receives the most direct sunlight in winter is the Tropic of Capricorn. And notice the Tropic of Capricorn is in the southern hemisphere. That's why it is summer for them and winter for us. And during spring and fall, when we're not tilted away or towards, notice that, the part of the Earth that receives the most direct sunlight is the equator. And that's why those two seasons tend to be in the middle. They're not the hottest, they're not the coldest, because the equator is getting the most direct sunlight and it is distributing the heat equally. In winter, we're tilted away from the sun, and our days are shorter, and we receive less direct sunlight, which we call indirect, which is what makes it cold. Now, looking at this picture, I know that the STAR test loves to do images like this. We don't actually have 4 Earths, so that would be a limitation of this model, but it's trying to show you the motion of the Earth as it revolves. Notice that every half of the Earth that is facing the sun is in day, and the other half is in night. So what I want you to notice is right here, if the northern hemisphere is tilted towards the sun, we call that summer. Look at the North Pole. Notice that if it is to rotate, meaning it's just going to spin, that North Pole actually receives 24 hours of daylight. That is why sometimes Alaska is known as a land of the never-ending sun. If you actually were to go to Alaska or the North Pole on the first day of summer, which is June 21st, you would experience a 24-hour day. Now, go over here when we're in winter and we're tilted away. Notice that as if the Earth was to rotate, the North Pole would not receive any daylight. And that is called the winter solstice, which is the first day of winter. And so on the first day of winter, which is December 21st, we would receive, or the North Pole would receive exactly 24 hours of night. And in spring and fall, notice how it is exactly half and half. Again, these are what we call equinox. And this is where the entire Earth, every latitude, gets an equal amount of sunlight. So just remember, equinox, equal day and night, equal amount of sunlight. Okay? So I hope you have everything you need to know about seasons. If you still have some questions and you're not sure that you truly understand the reasons we have seasons and what causes day and night, I need you to let me know so maybe I can work with you one-on-one, because we are going to be having a quiz over this soon. I hope y'all have a good weekend, and I enjoyed our first week of school.